Good morning, students. Welcome to a fresh session. So today we'll be continuing with our previous class where we have stopped. We have started to learn how to rationalize the denominator, right? So let's see this number. How do we rationalize the denominator here? First step is I have to look at the denominator of the number and select the conjugate of the denominator, right? So the conjugate of 7 plus 3 root 2 is 7 minus 3 root 2, right? We have seen in the previous class how to find the conjugate. So you have to just reverse the sign, right? So 7 plus 3 root 2 will be 7 minus 3 root 2, right? So 1 by 7 plus 3 root 2, I'll have to multiply it in the numerator and in the denominator by the conjugate. So I'm multiplying it 7 minus 3 root 2 divided by 7 minus 3 root 2 in both the numerator and the denominator. I have multiplied it. Okay. Now what do? I multiply it normally. So 1 into 7 minus 3 root 2 will be 7 minus 3 root 2. 7 plus 3 root 2 into 7 minus 3 root 2 will be 7 plus 3 root 2 into 7 minus 3 root 2. Right. Now the numerator, I don't have to do anything. I just need to leave as it is. So I just left as it is. Then now I open the bracket, and in order to open the bracket I need to use some formula. If there is no formula applicable, then I can always use opening the bracket by myself, right? So here always you can use the formula. Okay, there will always be a formula to use here, especially this kind of formula, a minus b, a plus b, or root a minus root b, root a plus root b, a square minus b square, something. Okay, so now look at this. This can be compared to this formula. As you can see, this can be treated as a, this can be treated as b. Again here a, b. Why? Because it's the same number. 7, 7, 3 root 2, 3 root 2. And here it's plus and here it's minus, right? Now you must be wondering why we can't use the formula a plus root b and a minus root b. Why can't we use this formula? Because clearly you can see that there is another number here, right? There is another number here. So we cannot use this formula, okay? So that is the reason why we are using a minus b, a plus b formula, okay? So this is comparing this to this. I can see that 7 is a and 3 root 2 is b. So now 7 square, the formula's expansion is a square minus b square. So I use 7 square minus 3 root 2 square. So 7 square is 49. I wrote it directly. 7 square is 49, as you can see. And 3 root 2 square is, let's find 3 root 2 square. How do we find 3 root 2 square? Right? So 3 square, first of all I'll have to write 3 square. 3 square is 9. And as you can see, these two are in multiplication. There's no symbol in between. It means multiplication. So I put the multiplication sign. 3 square is 9. Now root 2 square. What is root 2 square? I know that root 2 square is 2, right? Whenever you take the square of root, what do you get? The inside number, right? Root 2 square will be square and square root will cancel. It will be the inside number, right? Square and square root will cancel. I'll get the number inside the root. So 3 square was 9 and root 2 square is 2. So 9 2's are 18. So that means 3 root 2 square is 18, right? So what do I write? I write 18 here. So as you can see, 7 square is 49, 3 root 2 square is 18. So I got 49 minus 18 below, right? So numerator remains as it is again. Since I don't have space below, I'm writing it here. 49 minus 18 is 31, right? So let me explain this question again from the beginning once. Here we are going to rationalize the denominator. Why are we rationalizing the denominator? Because the denominator here is an irrational number. As you can see here, irrational number. Now, you have to remember one point. Root 2 is irrational, right? So you must be wondering, how did 7 plus 3 root 2 become irrational? So here, whenever you are given a question to rationalize, it is obvious that it is an irrational number. That is the reason why they have given you to rationalize it, right? So, but before that, you have to know how to identify rational and irrational. I've already told you how to identify rational and irrational, but you must be wondering, we have only done root numbers, and how did 7 plus 3 root 2 become irrational, right? So you have to remember that whenever you have an irrational number, if any number is multiplied to that number or added to that number or subtracted to that number, it does not matter. It is still irrational, okay? So here you can see root 2 is irrational, and with root 2, 3 has been multiplied, so 3 root 2 is also irrational, and 7 has been added to this irrational number, but also this entire thing is also still irrational. So irrational number when you have, and when you add or subtract or multiply any number to it, it will still be irrational itself, okay? So here you can see this is irrational below, right? So we have to rationalize this denominator. So how do you rationalize it? First you take the denominator and you find the conjugate of that denominator. So here 7 plus 3 root 2, conjugate is 7 minus 3 root 2. Don't get confused what conjugate is. In the previous video we have seen what conjugate is, right? So we take the conjugate and we multiply above and below, okay? Now in the numerator and in the denominator. Now our process is to multiply them. So 1 into this will be this itself, right? 1 into anything is that thing itself. So 1 into this will be this itself. So 7 minus 3 root 2 itself. So I write 7 minus 3 root 2. Then after that I multiply this and this. So I put them in a bracket and I put the multiplication symbol in between. But here I don't need to put, because multiplication symbol, it's naturally understood that there is multiplication symbol, right? So I multiply this and this multiplication, right? Now when I look at this, what do I see? I see that it's 7, 3 root 2, 7, 3 root 2, and there is only sign difference, plus, minus. So I know that I can use this formula. So according to this formula, I'll treat 7 as A and 3 root 2 as B, okay? And when I do that, what do I get? 7 square minus 3 root 2 square. So I write that below. 7 square minus 3 root 2 square. So 7 square is 49 and 3 root 2 square is 18. So I find the square and I write it in the next step. So numerator remains the same. 7 square 49, I write it below. 3 root 2 square is 18, so I write that below too. So now 49 minus 18 is 31. So I write 31 here and the numerator remains the same. Now after reaching a 31, can you see that 31 is a rational number? 31 by 1. So 31 is a rational number, right? So whenever I'm given a question to rationalize, the moment I get a rational number, I'll stop my process there. So I got a rational number in the denominator, so I'm stopping here and this is my answer, okay? So this is same as this. This and this are equal. Question and answer are equal here. But the only difference is this number is represented in a irrational denominator here and in a rational denominator here. So it's the same number represented differently, right? So that is just an additional information. So the main thing is to rationalize the denominator, and you have rationalized it and you have written it here, okay? So we'll see a couple of questions ahead and you'll be able to do it more clearly. So please watch the video again and again so that you'll be clear with these things, okay? Rationalize is a very important and very easy concept, so you have to know this. Next. So winding up this, we'll be starting with exercise 1.5. This is our last second exercise, and after this exercise we'll have only a little bit of portion remaining in this chapter. So let's read the first question. First question is, classify the following numbers as rational and irrational. So we have to look at the numbers and identify whether they are rational or irrational. Okay, let's see. First question, 2 minus root 5. So 2 minus root 5. Now look at this, root 5 is irrational. We know that, right? So how do we know that? Because we have studied in the previous videos how to identify, right? So root 5 is irrational, and I've said in the previous question I explained to you that whenever we have an irrational number and when we multiply or add or subtract any number to it, it still is irrational, right? So here root 5 is irrational and I subtracted 2 from root 5. So does it make it rational? No, it is still irrational, right? So I write irrational number. Okay, if it was 2 plus, it will still be irrational. If it was 2 into root 5, it will still be irrational. If it is root 5 divided by 2, it will still be irrational. Why? Because if you add, subtract, multiply or divide any number to an irrational number, it will still be an irrational number itself. Okay. Now the next question, 3 plus root 23, 3 plus root 23 minus root 23. So first I need to remove the bracket. So what do? I just remove the bracket and I write it 3 plus 23, root 23, right? Now the next word was remaining, minus root 23. So I write minus root 23 here. Now as you can see, this is root 23 minus root 23. So root 23 minus root 23 is 0. So because anything 3 minus 3 is 0, 5 minus 5 is 0. So like that, root 23 minus root 23 is 0. So I write 3 plus 0 is 3 itself, right? So how do I solve this? First I open the bracket, I write as it is, then I write this as it is. Then I can clearly see that root 23 minus root 23 is 0. So 3 plus 0 is 3. And I write 3 is a rational number definitely, because 3 can be expressed as 3 by 1, right? So 3 is a rational number, okay? Now the next, 2 root 7 divided by 7 root 7. So as you can see, there's multiplication symbol in between them, multiplication symbol. Now can you see the multiplication symbol? No. But whenever there is no other sign, right? There's no plus, there's no minus. So you can clearly understand that it is multiplication. So when there's multiplication sign, you can definitely cancel numerator and denominator. So you can see root 7 and root 7 is the same thing in the numerator and in the denominator. So you cancel them. Root 7 cancelled, root 7 cancelled. You get 2 by 7, right? So 2 by 7. Now 2 by 7 is clearly a rational number, right? So these 3 questions we have done. Now let's see the next one. Next one is 1 by root 2 is definitely irrational number, right? So why? Because root 2 is irrational, and I told you already, when we add, divide, multiply or subtract any number from an irrational number or to an irrational number, we still get an irrational number. So here 1 is multiplied to 1 by root 2 and it is still irrational. Why? Because root 2 is irrational, right? So this is irrational. Now 5th question, do it as a homework. As we have done 4 questions, the concept must be clear to you now. So please try it, alright? The next question. So we are going to do this question now. They have told us to simplify the given expression, right? So this is the given expression and we have to simplify this. Now how do we simplify something? In order to simplify, in order to arrive at an easier answer, simplified answer, we need to use formulas, right? But here, as you can see, we cannot use the formula which we have learned in the previous videos. Why? Because in order to use the formula, both the brackets should have the same number, AB, AB, or root A, root B, root A, root B, or A, root B, A, root B. So it should be the same numbers in both the brackets in order to use the formula. But here you can see that it's different numbers. Here it's 3 root 3, 2 root 2. So different numbers. When different numbers come in both the brackets, what should we do? We should naturally use the opening the bracket method. Okay, opening the bracket method. So how do we open the bracket? We have learned in the previous video how do you open the bracket. You take the first element of the first bracket and you multiply the first element of the second bracket. This is the first step, right? Then you take the first element of the first bracket and you multiply the second element of the second bracket. And now you can see that the elements in the second bracket is over. If there were more elements, you'll do the same thing. You'll keep on multiplying with the first element, okay, as long as the elements finish. Now, let's see, 3 into 2, 3 into 2, 3 into root 2, 3 into root 2, right? Now the next one, you take the second element and you multiply it with the first element. Then again you take the second element and you multiply it with the second element, right? So this is our method. So root 3 into 2, root 3 into 2, and root 3 into root 2, root 3 into root 2. And you can see there's plus symbol here and there's plus symbol here. So everywhere we have given plus symbol. Plus, 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 right? So that was the reason. Now let's solve. So after opening the bracket, normal solving. How do we solve? 3 into 2, 6. 3 into root 2, 3 root 2, because you can't multiply it, right? Since it's an irrational number. So 3 into 2, 6. 3 into root 2, 3 root 2. Root 3 into 2, 2 root 3, right? Root 3 into 2, 2 root 3. First you write the number, then you write the root. Now, root 3 into root 2, what do you get? We have learned the formula in the previous class already. What was the formula? The formula was root a into root b is what? Root a into root b is root a b, right? So root 3 into root 2 is root 3 into 2, right? So root 3 into 2 is 3 into 2 is 6. That is the reason why root 3 root 2 became root 6 here. Okay, we use the formula. What formula? Root AB is equal to root A into root B. We have seen this in the previous class, right? Yes, so we use this formula here. So root 3 into root 2 is root 3 into 2. 3 into 2 is 6. So we used that formula here. Okay, so now you can see that there is no number that I can add or I can subtract. There's no way to simplify this further. 6 normal number. 3 root 2 and 2 root 3 I cannot add because the roots are different. Root 2, root 3. If it was the same roots I can add, but here different roots, so I cannot add. Root 2 is different from root 3, right? So I cannot add, so I leave it as it is. Now root 6 I cannot add with 6. Why? Because this is a normal number 6 and this one has root, so I cannot add both the numbers, right? So you can see that this is the most simplified form of the answer. I cannot simplify it further, so I leave it here because this is my answer. Okay, now the next question. Next question is this. Now you look at the numbers, you can see that in both the brackets the numbers are the same. 3 root 3, 3 root 3. Only the sign is different. So definitely you can use a formula. Which formula? The formula that we have studied previously. A plus root b, a minus root b. So 3 plus root 3, 3 minus root 3. So you can see that a is 3, right? You can see that 3 is a and root 3 is root b, right? So you can see that a is 3 and b is 3 as well. So you can see a is 3 and root b is root 3. So what is b? B is the number inside the root. B is the number inside the root, right? So b is also 3, a is also 3. So you can see that I substituted it here in this formula, 3 square minus 3. So that is how we got this 3 square minus 3. Okay, so I use the formula on this and I got this. So try to use the formula and see. Okay, so when I got this, now I'm going to solve it. 3 square is 9, 3 is 3, 9 minus 3 is 6. So I got 6 as my simplified answer. Okay, now the next part. Next question. Root 5 plus root 2 the whole square. So obviously you can see that we can use the a plus b whole square formula. What is a plus b whole square formula? A square plus b square plus 2ab. So I can treat root 5 as a and root 2 as b, right? This is treated as a and this is treated as b. So let's see. Now a square, so root 5 square, b square, so root 2 square, plus 2 into a into b. So 2 into root 5 into root 2. So 2 root 5 root 2, right? Now root 5 square is 5. How? Root 5 square. So how do you remove the root 5 square? The root and square cancels and whatever is inside is our answer, that is 5, right? So same way root 2 square will be 2. So root 5 square is 5, root 2 square is 2. And 2 root 5 root 2 is again 2 normal numbers, so leave it as it is, right? Root 5 and root 2 I can multiply. Which formula do I use? I use the root AB formula. Root AB is root A into root B. root a into root b. So here you can see root 5 into root 2. So that will become root 5 into 2. Root 5 into 2 is 10. So root 5 into root 2 is root 10, right? So nothing, you just put a common root and you multiply the numbers that are inside the root. 5 into 2, 10. So root 10. So 2 root 10. Now 5 plus 2, normal numbers, so I can add them. 7 plus 5 plus 2, 7. Then I write 2 root 10 as it is, because 2 root 10 I cannot add it with 7. Now don't add this 7 and 2 and keep. No, because this is 2 root 10. This is a separate number, right? So if this 7, one second, let me clear it out for you. If this 7 had a root 2 with it, suppose it was root 10 with it. Suppose it was 7 root 10 plus 2 root 10, okay? Then I can add this 7 and this 2, and I can write 7 plus 2, 9 root 10 will be my answer. But here you can see that 7 does not have root 10. 7 is a single number. So 7 and 2 do not add. It's wrong, because 7 is a single number. What is the root along with 7? If you want to have a root along with 7, you can put root 1. Why? Because root 1 is 1 and 1 into 7 is 7. That is the reason. So that means roots are different. So you cannot add the numbers outside the root. Okay. So leave it as it is. So this is the simplified answer, which is 7 plus 2 root 10 is my simplified answer. So I have simplified it. According to the question, I have simplified my given expression. Now the next question. Now 3 and 4, question 3 and 4, I want you to do it as assignment, and I will ask you to submit it one of these days, and you will have to submit it. Before I tell you to submit, please do not submit. I've been receiving messages of notes and assignments and homeworks, but I do not receive those. Why? Because I did not ask you to submit it. When I tell you to submit, only then you have to submit. Okay. Next question 3 and 4, please do it as assignment, because it is the same concept and I want you to make your concept clear. So that's why I've given you the assignment. So make sure that you have done this assignment by yourself and you have thought over it and you have done it. Okay. Question 4, we have done several times, representing of rational number, irrational number on the number line. So please watch that video and please make sure that you do it properly by yourself. Okay. Because when you come to submit, I'll ask you how you did it. So make sure you do it by yourself and make sure you have understood and did it. So next question. Next question is again rationalize the denominators. So let's revise and let's do the question, right? Because we have done a lot of questions rationalizing. So let's revise and do the question. So what do? First we look at the number root 7. Why? Because root 7 is in the denominator and it is irrational. I have to make it rational. So what do? First I take the conjugate. So root 7's conjugate is minus root 7. And I multiply the conjugate in the numerator and in the denominator. So I'm multiplying it. 1 into root 7 minus root 7 is minus root 7. Root 7 into minus root 7 is, I write it as it is, root 7 into minus root 7. Now I know that by the commutative property, I know that A into B is equal to B into A itself, right? So that means root 7 into minus root 7 is same as what? Minus root 7 into root 7, right? So 7 into root 7, I can write it in the reverse manner. Root 7 minus root 7 I can bring here, 7 I can bring here, because both are multiplication. Will it make a difference? No. Why? Because we have the commutative property which tells us that the answer will be the same, right? So I use this commutative property, and in the next step, as you can see, minus root 7 I brought it here, 7 I brought it here. So it does not make a difference. Why? Because it's multiplication, right? Now you can see minus and minus, and there's no sign in between. So definitely negative number and negative number will cancel, right? So I cancel the negative number and I cancel the negative number, right? Now you can see that this is, don't cancel the root 7. See, look, some kids, what they will do, they'll come in this step, and then what they'll do, it's root 7 minus root 7 divided by minus root 7 into root 7, right? So what will they do? They'll cancel this 2, okay, and they'll write 1 by root 7. Now look at the answer. 1 by root 7, is it the same as the question? Yes, it is the same as the question. Now this, is it a rational number or irrational number? Irrational number. So can you say that you have made any change? No. So please do not do these kind of stupidities in your exam, okay? Because when you cut root 7 and root 7 here, when you cut root 7 and root 7 here, you will get 1 by root 7, and that will be the same as the question. So it will be like you did not do anything here, okay? So don't do that. Now minus and minus you can cancel. Yes. After that, root 7 is root 7 itself, and root 7 into root 7 is 7. You know that, right? Why? Root a into root a is root a into root a is a, right? So like that, root 7 into root 7 is 7, right? Root 7 into root 7 is equal to 7 itself. So 7 here, right? So now you can compare root 7 and 7. Which one you can know? You know that from the question itself, you know that this is irrational, this is irrational, and you have converted this irrational number into a rational number. What is the rational number? 7 is the rational number, right? So you have converted the irrational denominator into a rational denominator. All right, so that is what rationalizing is. So once more, let's see. 1 by root 7, what did I do? I looked at 7, I took the conjugate and I multiplied it above and below. So 1 into minus root 7 is minus root 7. 7 into minus root 7 is 7 into minus root 7. Now 7 into minus root 7, even if I interchange the positions, no problem, because it is in multiplication, right? So I interchange the position. Why did I interchange it? So that minus and minus I can cut. So I cancelled minus and minus. Root 7 remaining, I wrote it root 7. Root 7 into root 7 is 7. So I wrote 7. Now I can compare. I can see that this is irrational number. This is rational number. Root 7 became 7. So 7 is a rational number. When I get a rational number, I stop it, because my purpose was to find a rational number. So I stopped the question here. Okay. So this is my answer. Now next question. 1 by root 7 minus root 6. So 1 by root 7 minus root 6. Root 7 minus root 6. I take the conjugate. I multiply it above and below. What is the conjugate? Plus root 7, plus root 6, right? So when it was minus, I take the opposite sign. So I get the conjugate. So root 7 plus root 6 is the conjugate. So I multiply it above and below. Now 1 into root 7 plus root 6 is root 7 plus root 6 itself. Root 7 minus root 6, root 7 plus root 6. I multiply them both. So I wrote it like this, multiplication, right? Now after multiplication, I look at the numbers. Root 7, root 6, root 7, root 6. So which formula can I use? I can use the root a minus root b into root a plus root b formula. What is the formula? Formula is a minus b, right? So here root a is root 7, root b is root 6. So what is a? A is 7. What is b? B is 6. So I write a minus b. A minus b is my formula. So a minus b is 7 minus 6. I substitute, right? 7 minus 6 from this step, right? So I get 7 minus 6 is 1, as you can see. So 7 minus 6 is 1. So I get root 7 plus root 6. Root 7 plus root 6, right? So this is root 7 plus root 6 divided by 7 minus 6. 7 minus 6 is 1. So root 7 plus root 6 divided by 1, which is root 7 plus root 6. 1 is a rational number, you can see that, right? So I stopped it there. So my purpose was to find a rational number below. I did it, right? Next question. Again the same type of question, only numbers are different and sign is different. So 1 by root 5 plus root 2. What is the conjugate? Root 5 minus root 2. So I multiplied above and below. Then the above remains the same, root 5 minus root 2, because it's multiplied with 1. So root 5 minus root 2. Now this multiplied by this is this, right? Now again I use the same formula, root a plus root b, root a minus root b. So that is a minus b. So 5 minus 2. 5 minus 2. 5 minus 2 is 3. Now I can see 3 is a rational number. So I stop it there, right? And the numerator always remains the same. So root 5 minus root 2, root 5 minus root 2. And 5 minus 2 is 3. So I write 3 and I stop it there. Why? Because I got a rational number in the denominator. Okay? So this is what rationalizing the denominator is. It's a very easy one and a very important one. So make sure you have learned it properly. We have done around 6 to 7 questions of rationalization itself. So the concept must be clear to you now. Next, do number 4 as homework, and remember this process every time you study maths. First you study it, then you practice it, then you revise it, and you have to repeat this process. Otherwise no use, okay? So make sure that till you watch the next video, till I upload the next video of the next class, make sure that you study, you practice, you revise, and you repeat. Do this and I can assure you that you'll score a really good mark in your exam, okay? So make sure that you have done question number 4 as homework and you have done this process, alright? So study well and see you in the next video.